Okay, sorry about some of the technical difficulties here. So hopefully you can see my slides. I think maybe the one I was talking about is DoD HPC Modernization Program Office. I think this is an ecosystem. I think there are 5 major centers across the Department of Defense. 2 are within the Army, 1 Air Force, 1 Navy, and there's a 5th center at Maui HPC, really supporting the Space Force or Space Command, the new command which started. So the computing resources, I think each center is over the last 30 years or so, it evolved to support a lot of different classes of users, including industry and academia use our machines a lot for the classified or unclassified side of the house. So all these machines are connected to what we call Defense Research Union Network. And maybe universities, I think, places they can do. And as it is, we made good investments in the software applications point of view to see and then train some of the people in the DoD to really engage them. And this is a positive thing, but the other negative thing is because the way computers are evolving much faster, so the sustainment and maintenance of software is becoming more and more expensive because the software which was developed over the period of time, which is validated, a lot of things, people have confidence in that. And how do we move them to take advantage of the new things which are coming on board so that we're getting the performance? It's not like the machine is sitting there and we're not able to get the full performance. That means we are wasting a lot of the power and money also. So with that, I think next one, I think this is a background about where I come from, what are the things we do. And now I'll explain what is multi-domain, joint, all-domain command and control. I think if you look at the right side of the picture, I think if you look at what is this multi-domain means, multi-domain is it's a joint. So Army, Air Force, Navy, and now we have the Space Command, and then the cyber. Each one is its own domain, its own pipeline kind of a thing. But when we go into the battle, certain things, we need to get this information from all these things to make the decisions. And information at the right time is the key to make anything happen. And if you look at the right side, I think based on our adversaries, they're coming with new technologies, certain things a little bit faster than us, and we want to be ahead of them. And information dominance is one of the main criteria to do this. So how do we do this? I think maybe between all these things, maybe first of all, we need to sense the information. And once we sense, that is, how do we make sense of whatever we collected? What do we do? I think that's where the whole ecosystem is going to come. It could be your supercomputers, or it could be cloud, or it could be edge kind of a computer cloud, or it could be edge device. And we really want to take advantage of predictive analysis in the sense, how do we know we are right and we're right? And so that making sense based on that, then we want to act. And when we're acting, we are also collaborating with our partners across our NATO partners and other partners. So it is the whole thing we need to get these things. And then on top of that, the network. We have different classes of networks all along the way. How do we move this maybe data or information or whatever these things transparently? Because this is a contested environment. That means a lot of things are not going to work the way they're supposed to work. And the adversaries all the time, they're pushing borders to get disruption in different ways. including your machine learning algorithms, right? So, so that is the big challenge we have. So one of the things which we are really looking at, the effort in the whole thing is, how do we establish a data enterprise so that people can share certain things based on appropriateness? And how do we develop this human enterprise? Because we need different kinds of things. And the technical expertise, because new technologies are evolving, you need to integrate them. So the technical expertise is going to be part of that. And we have to share this information. So that is the big activity which is going with our domain. And command and control is like the decision makers at the top. They need that information so that they can do some things, right? So how fast can we give the information, whatever they need and what it takes? So, so this is one part of trying to explain the way we do business is there's requirement for this whole ecosystem is coming more because of the whole war strategies, a lot of things change. And sometimes I think maybe when I say contested environment, sometimes people may not get a good feel of that. I think if you look at, maybe we are thinking of autonomy, the human and autonomous systems interacting. And it is, if it's an urban warfare, and there are either drones or autonomous other things are going around along with the soldiers, and it is contested. That means your information, you're not sure you're going to receive the packets, what you're supposed to get there. And how do you act that? And so the contested environment is other important thing. It's not only the cyber, maybe they can make the sensors to behave something differently. Or the whole networks. So how do we give the whole picture about how we go about trying to provide that trustedness in that whole thing so that they can trust this technology? Okay, let me go to next one is, I talked about what is this multi-domain operations context concept point of view. And sometimes we want to picture them so that you'll get this is a big application area we're looking, these are the application drivers which is going to look and how we want to bring the technologies together. And meanwhile, I think within the OSTP, Office of Science and Technology to the President, 2 years ago, I think they developed a strategy plan. I'm part of this as a subcommittee member, pioneering the future advanced computing ecosystem. And it's not only the DoD problem, this is for the entire federal enterprise, a strategic plan. And the important components of this report, maybe if you get a chance, I would highly recommend you to look at it. And because as a follow-up to this strategy within the federal agencies, they developed an implementation plan, and also some of the agencies to have some plans for 5 years or 10 years, what are the types of things they're going to do. And the principal components on this advanced computing ecosystem is, one is the computing ecosystem. The second one is robust, sustainable software and data ecosystem. So this terminology is there. What is robustness means? What is sustainable? I think maybe a lot of people who develop software, they know the things. And earlier I talked to you about multi-domain things, so the data ecosystem. And then how do we get this new research into the whole thing? We apply the translational research and development activities and development of the workforce. So So some of the things we try to look at, what are the types of things drive these things? That's what I think we look at some of the applications really going to drive that. Then, for example, if you think about 60s man on the moon, that's a simple statement, but a lot of technologies evolved along with that. So sometimes some of these things is going to drive different technologies. And so some of the applications we started looking mostly, what is it? Extreme scale modeling. This would be exascale, that's a different class of problem. And data intensive sciences. And other thing is end-to-end and real-time applications. Maybe that's where we're really looking at how the cloud is going to be integral part with the whole thing. So those are the type of things which are driving this whole thing. So what are these? I already talked about, I think, we're looking at a federated set of heterogeneous resources. May not be one. Both, it could be a data, it could be your computational resources, or different experiments because they need to collect the way. Could be HPC or cloud or accelerator, network-centric, edge computing or non-monument one. And mostly we are looking at these things as want to make sure we do have the following attributes: reconfigurability, programmability, reliability, energy efficient. This is one of the things which I work on, trying to have some new way of looking at those things. What is the way we want to do this energy efficiency? And you can look at from not only your computing architecture or your processor point of view, maybe the way your algorithms can be, you can rethink certain things to see what is the best way to do. And out of all these things, security and privacy is other predominant thing across the whole ecosystem. So in my title, when I say advanced computing ecosystem, this is what I meant. I think we are looking at how this is going to help our multi-domain operations, all domain operations. In what way we can take advantage of these ecosystems. So, and I'm not explicitly talking about the networking here, but networking is part of the puzzle. So, so the next one is, I think, maybe software. I think I already talked about the software, I think, because we got a lot of legacy software. How do we adapt legacy technology to these new systems? How do we sustain and how do we maintain that? And how do we integrate with the new things? The reason why we have legacy application and all, because we spend enormous amount of time to validate all those things. So we do have confidence in those tools. So if we start rewriting from scratch, maybe then we need to bring back the whole thing. And then how do we get this open source software? What are the things that we can take advantage of open source software into this ecosystem? And the other thing is the data ecosystem point of view. Large data volumes are produced by this next generation instrumentation. No matter what, I think this data generation is becoming more and more. And recently, I was in some couple of meetings. I think this is one of the topics of talking about. President Biden was pushing for more climate, weather, energy, all these things. This data storing is going to be a big energy problem down the line. What it takes, we're not sure. I think we are trying to estimate, or we have to guesstimate something. But the way it is generated. So what is the right way of handling that? Do we need all the data? Or what is that we need to do? I don't have an answer. I'm not sure anybody has clear answers on those things. But it's like a tsunami. It's expanding, exploding at a much faster rate. And And so, and also how do we get the right data, the right information at the right place instantaneously, what it takes. Maybe certain things we doing that, but I think I'm talking about moving towards future when this explosion of data is going to happen. And so all these things are going to boil down to, for us also, the trusted software. Trust may mean different things to different people, okay? But even trusted AI is one of the activity which DoD is trying to get more and more. I think there are a couple of DARPA programs are there, but still, how do we know we are right? And we are working, we need to assume that we are working in a contested environment. That means my sensor is compromised, my communication is compromised, my algorithm is compromised. Under that context, I'm working on right there on the edge. So what is that trust I can build? How do I build the trust based on those uncertainties? What is that I can do? That is a big challenge. I think certain applications you can get by, and because earlier sometimes if there is a good physics behind all these things, maybe you can say I can go to the physics law and figure it out. This is not, once the data is there, it's nothing to do with physics or anything. So it is going to be a more challenging thing down the line to really look about that, but that is an area for a lot of interest within the DoD. And sometimes I don't look at these as problems. I look at these as challenges. So new research opportunities. Some new ideas will be there. We are looking at people to come with these new ideas about the place. That's what I think that in this whole ecosystem, the people is part of it. We need those new ideas. Okay. To sum up these things, I think maybe talked about advanced computing ecosystem, writing from HPC to cloud or HPC and moving towards quantum, and then all the software ecosystem, because down the line, I think we want to be this self-adaptive decision-making kind of a thing. That's what we are really pushing towards, so that the machines are going to help us. And one of the other big activity which within the DoD is going on, what we call DevSecOps. I know most of you are familiar with that, but I just want to, for some people, I just want to emphasize that. I think typically if you look at the software development cycle, you develop the software and you go through your verification validation process and say, it's doing what it's supposed to do. So then you pass on to somebody to use it, right? So, but here we want to implement the security right from the beginning. The security people has to be part of that, because we are going to move these things to different networks, different software, different heterogeneous architectures. And sometimes within our DoD, we have a lot of different networks. I think that's the other big thing. And different classifications are there. So we want to have the security as part of the whole development, and the security and operators working together. Operators could be the user community giving the feedback immediately, or it could be soldier, which and whatever they're using, they can provide the feedback. So the DevSecOps is one of the things is evolving more and more across the board. So we are hoping that is going to give us way of maybe sharing the software from one community to the other community, because as you know, within Department of Defense, we have whatever the way we say is science and technology community, testing and evaluation community, acquisition community, and operational community. Those are all the people who are on the field, right? And each one using different kinds of things. But here, when we're looking at this big joint thing, this has to be shared across all these things. Everybody has to be part of it. So it is a much bigger picture. We're trying to get what is that we need to get our hands around so that we can get all the people involved. Okay, let me go to the next slide. Yeah, meanwhile, if you have any questions or anything, feel free to ask me. I think then I'm going to talk about a couple of edge computing or edge HPC kind of examples which are done because give you a flavor about not specifically on the cloud, but cloud is integral part with these things. So one of the things, example, I think maybe this, the concept was more looking at if you have a scenario, say 100 drones are flying around, say a 50-mile radius, and getting that real-time situation awareness, and I want to track certain things in a way, I want to associate certain things, I want to do data analytics. That means I need to get all these drones, suppose they're going with a 4K video. I'm stitching that information, and then I'm going to do analytics on top of that. And you know that process, maybe I don't want to ship the data to somewhere else. Maybe I want to do those things right there at the edge. Maybe I don't want to take them and ship it. So if you look at that scenario, then once you get the video, then you need to convert that into so that in a point cloud way, so that you can get the images in a different way, because your camera position, if it is moving, the objects are moving. So there are a lot of other things are going around, and you need to stabilize the whole thing. And then once that is there, then you're trying to track certain things in real time so that you're identifying what is going on. And so this whole software pipeline, how do we get that onto some place where we can get some speed up so we can do real time? And so we try to do some, I think, propose some experiment where they're going to do data collection at some of the things which are going in while, and maybe we thought we want to use this our very high-speed network from the experiment is proposed at Rome, New York, and connecting that to Aberdeen in Maryland. So trying, and there is a big HPC machine just to categorize for this particular type of a job, and we want to really explore all the comms and how, because there are a lot of different devices in addition to the video analytics are going on. How do we fuse the information? That's the experiment we plan. And the part which I want to talk about here is we have bought a machine which is sits in an 18-wheeler. We can put that in an 18-wheeler and tow it around. So this has 22 IBM Power 9 along with 132 GPUs, about 330 terabytes of data, the storage. So, and some of the SSD storage and all, but still the power requirement is about 200 kilowatts for this one. But one thought process is we want to really go with the brute force to say, okay, I want to use this one so that I can get this amount of data I'm gathering, I want to process here. And what is the performance we're going to gain on this machine? And maybe that is one of the driving force to really assess what is that we can do. Still, we didn't go with 100 drones or anything yet, but I think that is our lofty goal. But I think at least going to that scale is what we are really looking at this problem to do. So how do we scale up the problem? How do we do that? Is still not a trivial thing, as most of you know. So yeah, we do have a thing, maybe the way some of the analytics, what are we doing, maybe we are able to get some things, but it's not where we are supposed to be. And the other thing is within our own, I work for the Army, so we really worry about geospatial data, especially if my vehicles are moving around, how they're going to go, and the soil conditions and all this. So how do I get that these things? If I have an autonomy for my ground vehicles, that means they're going off-road. They're going to go through bushes and trees and all those things. Maybe I need to provide them some additional information so that the autonomy is going to do better. So, so with this geospatial thing, I think we are looking at integrating along with the geospatial tools, whatever we have with this video analytics, so that some of the terrain information you can build up. So in a way, we are trying to get some of this information a priori so that we can use some of these machine learning algorithms, certain things to in place, so that the deep learning kind of thing is going to help us to fine tune the whole scenario point of view. And this is a little bit busy chart, but I think the one which I mentioned about this multi-drone edge. So we started looking at trying to divide and conquer kind of a thing. Maybe certain things we want to do on the core cloud, and maybe certain things we want to do on the edge. So we try to divide the problem so that we do in a way to solve the problem, because we are not only gathering the data, then we are tracking it, and then we are analyzing it to provide information. And when we are analyzing, I think earlier I told you, we do use some of this data which is generated from our geospatial things to really help us. That is the virtual data, right? That's to help with the live data. So that's what we combine. So I think we developed some pipeline to really get this process for one video analytics or two videos, something. So we are really looking at bumping up go to the higher, scale the problem up. And then one of the other thing immediately we noticed was we need to start thinking about our communications along with this one as an integral part, because this wireless communication, air to air or air to ground, and these routing protocols, a lot of things we need to fine tune to map to these problems so that we can take advantage, because we are really looking at the performance and how do we integrate, how do we get the synergy between all these things. Let me talk about security and privacy challenges. Even though when we are going of these things, security, how do we integrate? Because earlier I was talking to you, we want to think through when we are developing these things, okay, these are the possible things we need to expect. So it could be some malicious attacks, or it could be from some person sitting there, or it could be from the communication point of view, or it could be from a sensor point of view, or it could be some cyber related things, right? Anything, and some or misconfiguration point of view. So when our snooping kind of thing happens, so how do we understand those things a priori when we are doing this, the whole video analytics, so that I'm trying to build that trust behind the software so that we do understand certain things before we go to the next step. So, and for Army also the same things. I think sometimes we want to use this to train the soldiers at the end. This is one of the big things. Whatever we do, I think soldiers training is part of the whole thing. So how do we take advantage of these tools to utilize them to train the soldiers? So maybe some of times we may create some synthetic training, experimentation kind of a thing, so that they want to and mix with some of the real things so that we can train the soldiers. So we are trying to give them the realistic scenario. And these scenarios is, you can think of like a war gaming kind of thing, but still we want to do that. And if we have to do that at somewhere on the edge, we cannot really depend on the cloud and at some backend big HPC. Maybe what are the options we can do if I have a HPC in a small, say, Humvee or a truck? What is that we can do? How much we can really do? And I think maybe along this pipeline point of view, for the decision analytics, I think on our big HPC machines, I think really they develop a lot of new tools to help us with the synthetic generation of synthetic images. And what is the best way, including grass, trees, everything, maybe from a high performance computer point of view, they can generate the synthetic images, and how do we integrate them? So, and sometimes I think getting the synthetic and the real one really helping us in a lot of things. Maybe one of the example which is shown on the right, where from the image point of view, when they try to do images from the top, just looking at those things, they were able to identify only 3 out of 5 identified things, even though they are there. But once they got this augmentation and the machine learning point of view, I think it's much better. They were able to get 5 out of 5 identification. So this is a simple example, but I think just to prove the concept that we can do that. And then we also extended the similar concept of, can we do this cyber analytics at the edge? So I think our Pacific Command on the West Coast in Hawaii, all the network kind of things they want to be able to do their analytics on the edge there. Yeah, maybe training algorithms and other things they want to connect back to get those things, but a lot of certain things they want to do it there. So, so we worked with them in speccing out a machine. So they established a small, like the size of a half refrigerator kind of a box, big box. That's what the whole thing is. So where they can store at least 10 days of their data, whatever is going on, so they can use it for analytics. And they installed one there and one in Japan and connected through networks and cloud as a backbone. So, so this ecosystem, I think I'm trying to emphasize, I think we are trying to pull this from the cloud towards this other part. Maybe you can think of as a cloudlet or foglet, whatever you want to call. So that's what we are trying to get those things. And in this process, we also started working with Azure. Also, I think they came with some edge devices. When they came with their concept, I think they talked to us. We evaluated them to do some benchmarking to see how they're going to do, and if they're connected to their main network, the back end of these things, how they're performing certain things. So it's more of a collaboration work with Azure group just to get their ruggedized kind of thing. They got some couple of concepts. We try to help them out with these concepts. And then pushing, maybe earlier I talked to you this the autonomous or trusted AI. I think maybe for our ground vehicles, I think the concept is we want to have these autonomous ground vehicles off-road. And we want to be able to go as fast as they can. It's not like I can go only 5 miles per hour. No, we want them to go. So when they do that, when they're driving, how do they collect the objects and how do they go above the bushes by itself? How do we get the trust behind them so that they can do? So along with the synthetic modeling simulation tools, we are trying to help out and figure out what are the best ways we can assist. And it was interesting, even the soil conditions, certain things matter a lot. And the characterization soil into your autonomy is important because if you're making a turn, if it's a road, but if it's a soil, it's going to flip. So, and these vehicles are different type of vehicles. So how do we get that information, different information into, so that the autonomy could be better? And on top of that, I talk about this trust of your algorithms. How do you improve the trust behind all these things? So we are, because we are doing a lot of geospatial things, so we're trying to get those kind of information into this autonomous off-road vehicles point of view, so that we can get some of the soil characterization. But still, a lot of things, if it rained yesterday, there could be different conditions, right? So we are working on those aspects of it. What is the best way we can do? What are the bounds we can work on? Can we quantify that uncertainty and say, maybe I can live here with these conditions? What is that? The bounds. Still, we are working on those kind of things. And also, this chart is just to say, whenever we try to do these things, we want to establish some good benchmarking so that we understand, follow some process so that at least we're getting. So at least if you're looking at this new way the whole thing is coming, maybe I'm an older guy, I can think this way because when I was in the grad school and all, the only thing is x86. And we used to fight it out to make my algorithm to get performance as much as I can. I used to push that. Now it's not the case. I have innumerable things in front of me. And I have an application now. Based on application, I want to pick these things to say this is the best for my application, right? To solve this problem. So what is that benchmarking is going to help? What are the types of things I need to do? So that gives me a good flavor about for these applications, if I have this integrated couple of different things, as what I showed you, multi-domain operations point of view, a couple of things. If I want to do that, maybe I don't need a GPU here. Maybe I need something, right? So how do we make these decisions quickly? And industry is moving. And maybe Tesla decided they want to go with their own processor, right? That's what they're working. And Google said the TPU is this thing. So I think the customization is coming. But based on the application, how do we move? I think so. We are looking at how do we establish some benchmarking for these applications so that we can really make a good decision about what is that heterogeneous architecture is going to give best performance for my particular application that I'm going to work on. And now I think I move towards what we are doing some of the applications. And now I just want to talk a couple of things about the power efficiency. I think still power is a big issue on the edge. You want to do these things efficiently, even though I want to have a big box in HPC. And I talk to our own people. Well, I got my Humvee or I got my this one, but I need to use the power for all these things. I cannot give you this power. So they have their own limitations. So we need to work in that footprint about how much power is there, right? So then if you start looking at these things, out of all the things, the brain is the one, human brain is the one which consumes which minimum energy to do any operations. So we started, I think maybe most of you know, I think DoD funded this neuromorphic with IBM on the DARPA program. And still some of the efforts are going on really to understand what is that is going to give us that performance better. So I think some of the research also going towards what we call 2D laid materials. Some of the materials have different electronic characteristics which suits well. For example, I think there are some materials like molybdenum disulfate and all. If you apply some strains, you can increase the band gap or you can create a synaptic So sometimes I think maybe some places, maybe I don't need computing, I don't need data, I want some decision. Maybe that's what one of the things which we try to do with when we proposed that True North with IBM. If I have, for example, I have an acoustic sensor, so I'm throwing at this road, at the side of the road, because I want to, in the army, we want to find out what kind of vehicles went, what happened there. Right? So typically the process is we go and collect the data and run the math lab, and then find out, oh, this matches with this, so this is a M1A1 tank. But if I have this True North, that's what one of the things which we done. I can throw it there because it consumes only 80 milliwatts of power. With small other things, we add little things, but if it tells me directly, hey, 2 M1A1s passed by, so I don't need the data. I just need that information. Right? So certain class of applications, maybe we want to take advantage of this new way of doing business. So this 2D stacked materials is one of the new things which is showing promise. I think I know some of the universities are working on this one. I think some of the labs, I think we are funding certain things either from power and energy or mostly RF electronics point of view. We are really looking at a couple of things. So this is my slide. I think maybe this is what I tried to say. Maybe earlier I was telling you we are getting this heterogeneity more and more, right? So then if you try to group them together, and you can map them in a way to your human brain. If you look at the left side of the brain, usually that's logical, analytical. It can do some math kind of things efficiently. And that is similar to the von Neumann architectures. And the right side is more of random, probabilistic, subjective. And that's what this the neuromorphic or quantum kind of a thing, maybe that's what my view is, non-von Neumann, that is kind of thing. But still we are dabbling into this one, but the important thing is what goes on between the right and left brain. Could we integrate, right? That's a $1 billion question. I'm not sure I know exactly, but that could be the one. So for the type of applications we're doing, maybe this is one of the thought process. I think I just want to tell you this. For applications, maybe this heterogeneity in these architectures is going to give us to solve the problem in a better way. Because if I want to do some probabilistic problem with a lot of things, maybe my von Neumann architecture is going to take a lot of cycles to solve the problem. Maybe the other thing is helping. So one of the things which we are working on this topic, I think, before we are moving, maybe a couple of things, and I'll open for questions. Maybe if you get a chance, go to this. DoD has a software engineering institute at Carnegie Mellon University, and recently they wrote a report on a software engineering research roadmap. What are the areas needs to be focused? And there's some good information about the thought process, because the committee which formed to really give a thought process. It may not be the whole thing, but I think within the DoD, that's what we do. We try to get some good minds to think about, and they'll come, and some other study will come something, but as a whole, we'll be looking at what are the right way we need to go about. So if you get a chance, maybe I would like to suggest you to look at that report. It's a Software Engineering Institute report. So, and also recently from our AFRL labs, started looking at the campaign for the fog and edge computing. The one which I mentioned, the low power computing, is one of the driving force, because if you look at maybe Air Force, maybe Army, when I'm talking about Army, maybe I got a 18-wheeler I can take power around. But this is in a plane, F-22 or whatever, so they may not have that much power to do a lot of things, right? So the low power computing is one of the aspects. I think they're looking at what are the human computer interfaces, energy efficient architectures, and collaborative computing fusion. I think there's an RFP on the street. I think it went through the process right now. I think they requested kind of an abstract from industries. I think and some academia, they proposed some new ideas and they pitched in those new ideas. Nothing is funded yet, but I think some of the things are coming in this direction. I think these things may be coming more from the DoD point of view, because we are really looking at this heterogeneity is going to be helpful. So, and again, whenever we're looking at this collaborative, again, it goes back to all domain capability. What is that this is going to give us? And human computer interface is the other thing, okay, because human is going to be part of it, of the whole, whatever trusted AI or whatever all domain thing we are talking about. How do we get the interfaces in a way when, and also when the human is going to work with an autonomous thing, what is that interface is supposed to be? There are a lot of things are evolving, but that's an open area. Okay, with that, I think I'll stop and take any questions. Yes. Yeah, we'll take it.
Thank you so much. We know that, especially when AI comes to the multi-domain, especially with the autonomous driving, there's so many different tasks from different neural networks, and there. I wonder how you reason about this direction, because we see some multimodality fusion, model interactions, and what's the challenges in choosing how do you see this problem, especially with.
I think maybe algorithm, there are a couple of things. I think first thing is the swarming, certain things, maybe the algorithm point of view you want to go, but I think one of the other concern we have is the environment where we're working. The other factors that are going to influence certain things is what are the challenges are going to be more. I can get a good optimization algorithm, certain things to solve my swarming problem. But, okay, in the swarming, there are a couple of things. I change certain things in a way, or somebody's spooking happened. So what effect it's going to have on that? And how do I control that? How do I know that that's what I'm supposed to get, right? On the fly. So this getting this environment to other things, start thinking right in the beginning is going to be very helpful for us, because that's what I think it's not just I solve the problem, but I think when I'm working in that environment, I may not get what I'm looking for, right? So we need to get those things as a constraints right from the beginning of developing our own thing. So those are going to be the challenges, because for each application, there are different scenarios. That's what it's going to dictate. There's nothing like a single solution. But we can quantify and say, okay, within this environment, I can say, this is what it's going to be. Or if you can provide me, this is uncertainty, can you live with? So at least coming with those things is going to be very helpful for us.
So right now it's more still at the stage of people understand the dynamics and
yes.
the context.
Yeah, I think on compacting, and I think now the one which I'm posing is also because we have on the computing side, I do have the power limitations or other limitations, right? So is my algorithms maybe which processor is the best for my application? If you can come up with that, that's a good thing too. Because I don't want to have GPU for each and everything. Right? latest and greatest thinking is not going to be helpful. This is what happened. I think I talked to you about this cyber analytics for the at the PACOM, whatever, or Pacific Command. Initially, we have some NVIDIA DGX1, whatever the big box. So we gave it to them. And I said, why don't you experiment with this machine and all? Then they want to buy the machine. So then I really posed them to say, spec the machine based on how much data you want to store, what processing you want to do. Based on that, come up with something. And they came back and said, Raju, we are looking for a pickup truck and you give us a Ferrari. In the sense, the DGX1 is more expensive, a lot of things, right? They don't need that. So I think, in simple words, I think we need to get to a better way of, say, on a daily routine, we do have this idea. What does that mean? Yes.
Thank you very much for the interesting presentation. I'm actually curious. I would like to ask you to elaborate on this issue. So I also understand that there is a difference in the both topics in the central location and local, let's say, environment where in the battlefields. So practically, of course, we have many challenges there. It's communication, it's how to bring model to data, it's how to separate the concerns between local and central, let's say, targets, and how to reuse it. So my question is, what do you see the most challenging in this direction? So globally, or what is the biggest challenge? Is it communication? Is it separation of concerns? Is it data?
I think computing may not be a big challenge. I think the part is going to be more of the making sure that the information is coming at the right time. What is that means? It is that application is going to dictate what does that mean. So some of these challenges may not be more for communication in some applications, but some applications that's going to be predominant. And so, and also because even these communications are also, we are going with layers. And immediately, it's not only the cyber thing, the trusting is the other thing which is coming more and more. I think those are the challenges which we're going to do, but the application drivers for these things are the applications. But if you keep them aside, these are kinds of things which, if you need to push the envelope, I think when we go in these networks, for example, I think it is strange. I think we work on that. We work with NATO cut certain things. The Brits can know something in my data, but Australians cannot know that. Right? But they're on the same network. So what are the things we need to do? So what policies? What are the things? But these are all going to be something software defined where we want to do that. So this other software defined networking or any of these topics is going to be helping us to streamline it. So yeah, challenges are mostly some applications, the communications is going to be more challenging for us because, and sometimes I think with insufficient data, what are the things they can make?
Thank you.
Great. Thank you so much.
So is it okay if we share your email so that if people want to ask more questions?
Please, yeah, please. I think my email. I think maybe I'm sorry. I should have
Maybe it's
done that.
interesting.
Maybe I'll give it to you, or
Yeah.
maybe I can.
I can send attendees your email.
Yeah, please feel free to send me. I can answer some questions, or if I need to get you connected with somebody else, I'll say that's the right person to talk to because I'm not an expert in all these things, right?
Yeah.
Because so definitely, I think we are looking for help. I think as you know, this is even though we are funding certain things, still it is much bigger problem than what we can solve. I think it's one thing which we, across DoD we're struggling to see what community we need to bring, what kind of investments we need to push to really make it happen. So I think we are looking for bright ideas. I think, and the reason is whatever I talked about is only small, just surface scratch. I didn't go into a lot of details, but I think once you go there, and also I encourage you to maybe talk to some of the DoD. Maybe if you get a chance, visit a DoD lab. You'll get a little bit different perspective. I think that's one of the things I encourage people to take advantage to visit that. This is not a NSF research